Recording in progress. So welcome everybody to the first shading and lighting lecture. My name is Tony Saxon. I'm the course director here for shading and lighting campus and online. Welcome to our beautiful campus facility here. We've got 4 students on campus, which so far, not quite a record, but it's rivaling a record that I've had up to 6 people at one time. I think the month you were in. Yeah, but that quickly dropped off. So at the end, we're down to 1 person. All right. Try and make it to campus, but not a morning person. Yeah, well, time to get back into the morning routine because with Full Sail, you never know. When we get when we get rolling full tilt, your times are going to be all over the place because we do run 24/7 pretty much. Usually lectures not past 9 p.m. Labs, they try to keep not past 1 a.m. But, facility is open 24. All right. So what's that?
Kind of schedule I came here for.
Yeah, it's intense. All right, so our class is broken up into 4 parts. So first part, rendering. If you can't render, you're really not going to be able to show your work. I don't care whether you're a game art student or computer animation, film, visualization, simulation, it doesn't really matter, right? In the end, everything gets rendered, whether it's real time or whether it's software rendering for, film. But even that is changing rapidly. Real-time rendering is becoming attainable for the masses if only we could get a hold of the graphics cards to support them. Because there is a glut of people doing Bitcoining and bit mining to get virtual digital currency, and they're using the graphics cards to do that we would normally use for rendering and display. All right, so we render. We're going to do lighting. Part 3 is materials. Material properties, what makes things shiny, what makes things dull. And then we get into draping textures on top of our geometry. So texturing. Each one interconnected. If you can't render, you can't get anything to display. If you don't have lighting, you're not going to get anything to display. If you don't have materials, you're not going to get anything to display because those 3 things are key to making anything visible, whether it's the real world or whether it's CG. So the Zoom campus lecture link, I don't actually have it inside each activity anymore. We took it out and it is inside. Let me pull up. It is inside where is it? Here it is. It's inside activity 4. So if we go back, course overview, activity 4, there is the schedule. So you notice we're here a week and then it's summer break. Yay, everybody's favorite. Well, close to it. Your Zoom link is here. Now, this is only for campus students. If you're online, you're going to watch this video after the class is over. We archive it or I should say, render it out, upload it to our YouTube page, and then it becomes available to everybody. But for campus students, this is where you find your link. Because your course overview is slightly different than the online students. All right, so back to rendering with Arnold. All right. So today we're going to be utilizing a couple of scene files that we give you. That'll be your practice, your way to kind of get introduced to rendering. Rendering is not really that difficult, but it is time consuming and you need to be detail oriented. If you follow the right steps, you'll be perfectly fine. So we have an Arnold rendering workflow doc, which should make life a lot easier because I break down all the stuff you need to know in order to get a good render out. We're going to go over most of it for today because this does set you up for the rest of the course. The only difference will be project 4, we do animation, which means we render multiple frames. So it's a little bit different process than rendering out a single frame. So if anybody has any questions, please stop me along the way here. And let's just put this over a little more. Good. Okay. So let's clear that. So my name is Tony Saxon, as I mentioned. Email tsaxon@fullsail.com. I may have a phone number listed somewhere, but don't bother calling that because that is my desk here at Full Sail. And when we are not teaching, we are not at our desks. We're still kind of social distancing. So email, FSO message, best way to get a hold of me. Plus, we have a Zoom, or not a Zoom. Yeah, we have Zoom, but we also have a Discord server. So make sure you sign up for the Discord server. Link is in each activity. It's also in the welcome announcement. Make sure when you sign up that you go into our server, you're going to go to a landing page and you need to change your nickname to conform to our server standards. So just make sure you read through. We've got a little kind of rules of the road in that landing page. The process to change your status so you have full access to our Discord server is manual. So don't be too impatient if you change your name and it doesn't immediately give you access. So just let us know, hey, I changed my name. I realize it was the middle of the night, but when you get a chance, can you give me access? We'll be happy to do that. All right. We will take a 60-minute break between lecture and lab. Lab is inside this room. Lab will not begin. Oh, yeah, lab will probably begin around noon. Our lecture goes from 7 to 11. We might run a little bit over, but don't worry about it. You will still get a full hour between lecture and lab. Normally, I will have office hours on Tuesdays and Thursdays, but I have vacation time that I'm taking on this Tuesday, this Thursday, and then all of next week. So somebody have a question? I hear audio coming on. Haley, do you have a question? No? Okay. Don't forget, if you need to talk, you can hit the space bar. That will temporarily unmute you. You can talk, type in the chat. I'm trying to watch chat as I talk, keep an eye on everything. So if I don't get to your question immediately, don't worry, I will try and get to it. So anyway, this week, Tuesday, Thursday, I'll be out of the office. Next week, we are out. Campus is pretty much closed because it is summer break. So everybody gets a chance to relax. On Thursdays, we have what's called an open Zoom lab, which is optional. Open Zoom lab is for online and campus students. And basically, it's a chance for you to get some extra help if you need it. Now, you come to Discord, we can give you help also. We can even screen share in Discord. But if we get a group of people, Discord is not really friendly to a whole bunch of people sharing at the same time. So that's why we use Zoom. We can get a lot more people, pretty much unlimited number of people in there at once. So usually your lab instructor, Frank or Ari, will be running the online Zoom labs. They are from 1 to 5 p.m. Eastern Standard Time. Everything here at Full Sail is Eastern Standard, just because we are on the East Coast.
I think that the Zoom open one, I could be mistaken on this. I think it looks super closely to schedule, but I think that is at least a good part of that is during our lecture lab experience for our other classes.
Right. That's why this is optional.
Okay.
This is it. Not everybody takes 2 classes at once.
Yeah.
So if you don't take 2 classes, you want to get extra help, you can. You can also look at it as a way, if you guys have lunch in your other class, which is usually Portfolio 2 with John Piro, good friend of mine. You know, if you have lunch, you can always pop in there real quick for a question. So not a big deal. Where is your Portfolio 2 class? This here in this room? Okay, yeah, it usually is, because he and we usually have the same room, just different days. So he's Tuesday, Thursday, we're Monday, Wednesday, Friday. Oh, you guys are in the afternoons. 1 to 9. Okay. Yeah, probably. That makes sense. All right, so we will continue on here. All right, so if you are in the campus, or I should say on the campus in the classroom, classroom etiquette, this goes for lecture and lab. Please 3 feet of distancing at all times. Wear a mask in all indoor environments. At Full Sail, you know, walk in the door, put a mask on before you come in. In the classroom, when you go outside, feel free to take it off if you want. You can leave it on. It's up to you. Please wipe your areas down before and after you are done, just so we make sure everything's clean. Especially for you guys, you know, we're assuming the last class does the same thing and that we have people come in and wipe it down, but you still can't be too careful. So if you are sick, you must not come to campus, even with a mask. Not a good practice. Sign into Zoom instead. Get well, come back when you're ready. I do believe there is still a disclosure confirmation document that needs to be filled out. No? They do away with it? Okay. Okay. Party on. So that part's easy.
It's very nice to just show up and walk into the dark.
Yep. Well, I don't know if you were here when we were first starting up, that you had to come in, get your temperature taken, got a little sticker.
Yeah, it's actually really recent they stopped doing that.
That was last month, was the last time they stopped doing it. Yeah. Okay. So course expectations, we have 11 lectures, 11 labs. We have 7 assignments, which equate to our 7 projects. We have 1 strictly rendering assignment. We have 3 lighting assignments. We have an animation batch rendering assignment, or rendering multiple frames. We have 2, we have 1, 2, 3. Yeah, we have 3 lighting assignments, a batch rendering assignment. We have a material assignment, and then we have a texturing assignment. We have 5 discussions. 4 are topical. 1 is rendering, 1 is lighting, 1 is materials, 1 is texturing. And then we have a research discussion, which we will go over that when the time comes. So for today, the only thing you have to worry about is project 1, it's rendering. And of course, GPS is 10% of the grade. So if you guys have questions, please stop me at any time. Feel free to type in chat. If you're here on campus, just chime in, ask questions. All right, so campus students only, if you are attending, lecture begins on the hour. If you're late, make sure you let me know so I can give you attendance credit. Right now, I got everybody because I remember everybody's name. But just don't assume, just say, hey, I don't know if you saw me, I came in late, just so I can give you attendance credit because we are taking attendance. I will be taking Zoom attendance also. What I do is I will take a screenshot of my participants that will serve as first attendance. And then second attendance, basically second attendance is we're going to do a short 20-minute break in between the first two parts of lecture. Like lecture is 4 hours, so we take a break about hour and a half, 2 hours in, depending on what we're covering. And then we'll take a short break. That gives me a chance to render out the first part of lecture, so my computer's not overloaded. And then we start up and I can start a new part 2 of lecture. If you're late, make sure you watch any of the information in the archives that you may have missed, because we're not going to have time to recap everything. Attendance in the live Zoom virtual lectures is expected if you are not physically on campus. Get ready for campus only in the future. I don't know whether you guys saw it on Full Sail 1, but I believe, is it August or September they're looking to go? September. Yeah, okay. So September. I know next month they're going to try and push more to get more people, but then it's going to go hardcore in September where it's mandatory to be on campus. I always do Zoom anyway, just because it's a great way to record everything. And it's a great way for, if you guys can't see the screen, if we're in a, big class with a big room all the way in the back, you can always have it on your computer. Yeah, I've done it. Well, I used another program before Full Sail started using Zoom. It was called GoToMeeting. I always ran that and I always recorded my lectures. Only because it's the best way for me to get you new information every month, rather than try to make little videos of which don't have time for it. So since I'm in lecture, this way campus and online students get the same information. So, like I said, if you are not physically on campus, you are expected to attend the live virtual Zoom sessions. If you cannot do that, you must message me and I will give you some instructions on how to get attendance. So, well, here it is anyway. You're going to send me a message saying, hey, I missed lecture. I missed the live Zoom lecture. And you need to make sure that you watch the archive and send me a screenshot of it on your computer and say, hey, I watched this lecture. And that way you are saying, I watched this, and that serves as our legal attendance. All right. So SAL checklist, basically. Yep.
All right, thank you.
You're welcome. Basically, we have the same kind of disclaimer for campus and online. You really need to watch the campus lectures before you try to work on any project if you didn't attend the live session, because we go over the theory involved in each project and also demonstration on how to use the tools or demonstrate the concepts. Now, I don't give you step by step, this is how you do this, this is how you do that. Don't have time for that. So we usually give you an overview. And if you have specific questions on anything, or you're having a hard time with a specific area, that's what labs are for. So our lab guys, or lab people, I should say, Ari and Frank, are really good at being able to troubleshoot and demonstrate stuff. So please take advantage of them. All right, so checklist, check your email, check your messages often. Honestly, you should have your email running all the time. You should probably have FSO all the time open. when you're working this way, you can respond to messages and emails in a timely manner. Just a word of caution, don't send me any emails with attachments. For whatever reason, my Full Sail email quarantines most things with attachments. So if you need to send me something, put it in an FSO message, attach it there, send it to me. This way I can be sure I get it. So if you're on campus, no earbuds, no headphones during lecture, unless you're listening to questions on Zoom. I have earbuds in so I can hear anybody here, but normally I would not. I would just record lecture. And well, the fact that I have earbuds in with a microphone makes the audio come out a little bit better. Before I was just using my computer mic, and it's okay, not great. All right, make sure, put your phones on silent, please. I forgot to do that to mine. There's nothing worse than having a reminder go off, or somebody text you, or you get an email, you get the ding or the whatever sound you have. Screaming people. We are very technical, so please take notes. I can't emphasize that enough. A lot of times people will say, yeah, that makes sense, that makes sense. But 5 minutes later, like 50 other things have gone by and you kind of forget. So please take notes. Get yourself a breadcrumb trail so you can get back to the concepts and understand what's going on. And again, if you guys have questions anytime, please feel free to chime in. In Zoom, type it in, hit the space bar, unmute yourself. All right, take responsibility for actions, mistakes. It's a lot easier to solve or take care of a problem when it happens, and we deal with it right away. Don't let it, go by and assume everything will work out. Don't do that. It doesn't work. If you have problems with Maya or delivering your work, own it. See it through to completion. Not because we're mean, nasty people, but part of your education here at Full Sail in every class is troubleshooting. Troubleshooting different aspects and elements of our industry. And software malfunctions and networking issues are always going to be with us. They are not going to go away. I don't care how good software gets or how good, the hardware that we put on them, your computer, how good that is. We're still going to have software crashing, corrupting files, network issues, power failures are another big issue we have here in Florida. Especially if we have, pretty decent storm. They've been known to happen once in a while here, called hurricanes. Ask for help after you've tried to solve the problem yourself. So if you find yourself spinning your wheels after about 10 minutes of troubleshooting, you're back at the same, starting place, you can't figure it out, then it's time to ask for help. Now, if we're not around, Discord should be your next best place to ask for help. Nobody's on Discord, fellow students, it's really quiet, nobody's answering. Just send a message, send an email, get to it when I check my messages and email in the morning if it's in the middle of the night. Use empathy, understanding when engaging with other people and their differences. That is really, really important now that we're doing a lot of things virtually, because we tend to have a different way of communicating when we type and it's faceless on a keyboard than when we are face-to-face with people. So try to imagine yourself face-to-face with that person. And that's really how you want to handle it. You want to be able to try to read underneath of what's being said sometimes, because sometimes when people are frustrated, they're angry, they say things they don't really mean, but it's just frustration talking. So when you're dealing, especially in the industry, you're under a lot of pressure with a deadline, with a lot of work. Working in teams is always a very interesting thing because you're relying on other people. So just take a step back, take a breath, and try and deal with it as compassionately as possible. Learn patience, because nothing happens as fast as we want it to, especially with rendering. So rendering is just one of those things where it's time-based. You can't really make it go any faster than the computer can handle it. So, you have to allocate for that. In fact, if you're ever working on a film or you're working on TV and you're rendering stuff, they've got time budgeted for rendering. You have to actually budget that time. Don't finish your assignment 2 minutes before midnight and expect to be able to render it out and get it uploaded to Full Sail in 2 minutes. Quite frankly, that's unrealistic and is not going to happen. Today, rendering, we're going to be doing full environments, and your render times are going to be anywhere from, 10 minutes to a half hour. So you should be able to get a pretty good idea of how long rendering will take after today. Now, when we get into simple lighting, it's going to be a lot easier because we're dealing with a single light and very simple geometry. But today we're dealing with multiple lights, multiple sources, and a big environment. All right, learning is difficult. Don't let anybody tell you differently. If it weren't difficult, you wouldn't need to be here at Full Sail. You could get everything on the internet, which, you can learn how to do surgery if you really wanted to on the internet. Somewhere there's, step-by-step instructions on how to do an appendectomy on yourself. Don't do it. But it's just an example of stuff that you can do. So just because it's there doesn't mean we can't master it. It's one of those deals where it may look completely foreign to you, but after you learn and understand the technique and the process and the reason why you do certain things, it makes sense. And that's what we're here to do. We're here to break down all the information on the internet that's out there generally in the world and try to give you guys a good foundation for how to render, how to light, how to use materials, and how to basically do some texturing. You're not going to be a master with everything, but we're just trying here to give you a foundation. Honestly, each one of our aspects of our course could easily be a month long. To be able to render, to be able to lighting could be a whole semester of traditional college. Like, actually, I've seen lighting, photography, stage lighting, film lighting. I mean, there's 2 or 3 years worth of information there, literally years in a traditional college. But we're just trying to give you foundations. So stick with it. It can be frustrating. It will be frustrating, but stick with it. Sometimes that, I like to call it the path of most resistance, something that, really is hard for us to do. If you stick with it, a lot of times that can be the most rewarding. Because if you come across something you can do easily, a lot of times we take it for granted and we don't necessarily appreciate how hard it is to do. Like, we all come in to this world with certain skills that we're just kind of enabled with, things that we're good at that we gravitate to and we go, yeah, I understand how that works and I'm able to do it. And then other things we look at and it's like, whoa, I don't understand this. Like I said, those are the things that if you work at and stick to it, you will get. And like I said, that can be very rewarding. You may not want to do it as a career, but you learn it for use when you need it. All right, so if you need to send me an email, please use the Full Sail approved student email subject heading format, which is basically our course code, GRA1161-L. Our term ID, the month, is 2021-07, and our section for campus is always 00. If you're online, yours is going to be -C or -O for online, and then you'll have a section number. And then whatever issues with my project or whatever your title happens to be, your subtitle for your subject matter. Now, if you forget, we'll send you a reminder, friendly reminder. But if it's a consistent, you're ignoring the heading, then we're just going to go, we'll answer your question when you give us the proper format. Not because we're mean, but because got to make sure that you use proper communication skills so you can get a job. And not only get a job, but keep it. All right, classroom guidelines, no food or drink. It's okay if you guys have bottled water, if it's capped, that's perfectly fine. But no sippy cups, no coffee cups with the plastic lids where you knock them over and they open up and spill. That's, doesn't make anybody happy, especially the cleaning staff. They have to come in, clean up the rug because it's usually a sugary drink. So please ask questions at any time during lecture or lab. Please do not share files with anyone or do someone else's work or try to use someone else's work, pass it off as your own. I have to say that because it does happen. But we are a very, very small industry, and believe it or not, these things travel very quickly. If you have a reputation or someone has a reputation of, trying to use other people's work, you're basically going to have a lot of trouble getting a job. So if you have any questions as to whether something constitutes a violation in that academic integrity, ask me, please. I'd rather have you ask, and then we can figure out what you need to do. Now, if you suspect somebody else for some reason is using your work, if you're not comfortable confronting them, make sure you let us know. Use of profanity can be counted against you, not because we're prudes, but because there is situational awareness. There's a time and a place for everything, especially at work. Your boss bringing clients through is not a good time for you to rage on about how stupid Maya is, or Photoshop, or whatever program you're using, like Unreal crashed for the 70th time and you lost your level. It happens. So if you feel the rage, just go out back here at Full Sail and scream at the wildlife. They love it. That's why it's so lush here. Lots of squirrels, they love that stuff. They're like acorns to them. All right, so any issues with class, bring it to my attention. If you're in lab, bring it to Frank or Ari. They'll be happy to help you. If you're a repeating student, please do not reuse old assignments. Do new versions of the exercises. If you have any questions, ask me, please. This one? Yep. I believe that's also in the bottom of the policy activity too, this information. So, all right, so where is the information? Well, everything is in FSO. So let's go here. All right, so course overview, objectives, outcomes, reading. This will take you to our O'Reilly books online. We're using Jeremy Burns' Digital Lighting and Rendering, really good book. He is a lighting TD at Pixar, or at least he was. I think he moved to ImageWorks, DreamWorks, one of the other works places. He travels around. He's really got a good book. In his book, if he gives examples, he uses Maya a lot of times, but all the information there is usually good for any platform you're working on, whether it's Blender or Max or Cinema 4D or Maya. Doesn't really matter what it is. All right, so got a couple of links here that will take you to the Arnold/Maya help docs page. In addition to that, like I said, we've got a Discord link. This will take you to our server so you can sign up. Campus lecture archives are here. This will take you to our YouTube channel. The newest lecture will show up at the top. Like today will be 2021-07, lecture 1, since we're the start of the July term. Yeah, lecture 11, that's our ACD, Tony Bagsby, that's his dog, Amy. She's a corgi. So he loves to put her in everywhere. Software, we're going to be using Adobe Photoshop, make sure it's working. After Effects, part of the Creative Cloud. I just got a notice from Adobe and Substance that they are now, for you guys, I think immediately rolling. If you don't have Substance Painter, which most of you probably do have it, if you don't have it, it's being rolled into the Creative Cloud suite for you guys. So it's going to be this, and also they're keeping Substance Painter, that same name, but there was a Substance Alchemist, which was basically, you can process textures and images. It's not a painting tool, but it's more like a kind of texturing, UV layout kind of program. That's going to change names. I'm not sure about Designer. Those are really the three big ones: Designer, Painter, Alchemist. We use Painter for the most part. We do use Photoshop for texturing. Basically, this month, you're going to use pretty much everything that we have, just so you know how to do something in each one of the apps. We have a Arnold rendering workflow doc here. This will take you to our OneDrive. It pops in as a PDF, so if you want to download it, you can. But I go through basically describing the Arnold render view, what this, where all of the switches, the buttons, the settings are, so that you can get a good, decent render out of that render view. The render settings, some of the changes that you might need to make, we'll go over these in lecture. We're going to start off very simple, but as we add in materials being shiny things, metal, glass, our render settings are going to change because we're going to be adding more components to the look of our objects. So we also get into working with live IPR and then rendering sequences, which allow us to do animation. So if you find something in that doc that's not spelled right, let us know. Or if you find something, hey, I saw this and thought it might be a good thing to include, let me know. So all the instructions are here for the project. Checklists, the different parts, what to include when you're getting ready to turn it in. We give you a screenshot of everything that we want from you, Maya scene files, and what we call target templates, because we give you templates that you put your render in and record render setting and render time information in. And then your downloads are always at the bottom. So that's where everything is. So like I said, lecture, we're probably going to do about 2 hours, maybe a little shorter, maybe a little longer. We'll take a 20-minute break. We'll come back. We'll finish the remaining with some demos, some explanation, like what you're going to be doing in lab today. And honestly, you should be able to finish, I'd say, 2/3 of your assignments before the end of lab. Maybe even the third part, depending on how quickly you work, but that's up to you. So take screenshots, take notes, take pictures, use Zoom. You've got the archives when they're done. And honestly, You know, with our help, you should not have any issues. All right, assignment deadlines. Please read our activity 2 policies under course overview. One thing is, if you think you cannot make a deadline, send a message, ask for an exception. An exception will give us the ability to keep the assignment open, but with an exception, there is a 10-point deduction each day it's late. That is Full Sail policy. That is not us. If you missed the deadline and did not ask for an extension, don't upload it to feedback, because we rely on the activity in FSO being completed. And if it's not completed, you stand a chance of getting an auto 0. So even if you missed it, the time has passed, send a request. I can always open it up, give you an exception.
This isn't like a situation where you, if the deadline's keeping up to turn in what you've got so far.
No, you don't want to do that. Yeah, you want to submit completed work, because that's what we're grading on. We're not grading on incomplete work. Or if you turn it in incomplete, we're only going to grade what you give us, and the rest you'll get a 0 for. So, and also another thing, please don't turn in bits and pieces like, oh, I turned in the first part, and then I turned in the second part, and then I turned in the third part. Turn in the whole thing. That way we don't misunderstand what's going on. Because if we have too many parts, we don't know which one to use. We don't know which one comes first. Always give us a complete package if you have to resubmit something. Like a lot of times people will submit stuff and go, oh, I forgot to do this to my template. So they'll go in, fix the template, they'll re-upload the whole assignment and go, hey, please use this version when you grade. That's the best way to do it. Because bits and pieces only cause misunderstanding. We don't do it intentionally, but sometimes we can't always read your mind. We try, but sometimes it's scary in there. All right. Don't send us a Dropbox link, Google Drive, OneDrive link. You know, activity needs to be completed. All right, software you will need, Maya 2020.4 preferably. The reason we say 2020.4 or the 4th update is because it contains the version of Arnold that we use in our class. Now, granted, there are other versions. That version of Arnold happens to be 4.2.1.1. The current version last month was 4.2.2, but I started up Maya last night as I was packing my computer up and found there's a new update to Arnold. So I didn't bother to update because I wanted to do it with you guys so you can see the process. But the newer versions of Maya will let you update Arnold by itself without updating Maya. And the new versions of Arnold, they fix bugs. They give you a little more stability for the most part, because the very first version of Arnold was good. Second version was better. I'm hoping this one kind of gets rid of some of the problems we had when we were trying to sequence render. We'll find out. Yes.
Since I'm coming back, I will not have my programs updated for Photoshop and the other creative until the 3rd week. That's what they say for the lunchbox.
Well, you still have working copies of it though, right?
For Photoshop, no, it doesn't let me in. I need to like sign in.
Can you still use Photoshop though? Okay, because you do need Photoshop to turn your work in.
Yeah, we asked yesterday, but whenever orientation was, when we get how to say it, to get Photoshop working again and stuff like that for my lunchbox, and they said like, oh, probably in the 3rd week when we start.
Okay, well, how long ago was this?
Last week.
Okay, contact them, tell them you need it for this class because you need it for every assignment. You shouldn't have to wait that long to get it.
I just came back, so.
Okay. Yeah, tell them you need it for this class and you need it like immediately because your first assignment relies on it. You can get After Effects. We're not going to use After Effects till we come back after break from summer break. Substance Painter, you probably already have that, so that's not a big deal. Unreal, you can download that. That's really not an issue, but Adobe seems to be an issue. So make sure you let them know, tell them, listen, my class, I need to have Photoshop. Okay. So anyway, the preferred version of Arnold is always the new one. Like I said, I've got 4.2.2, but there is a new version, which when I go to demo Maya, I'll show you guys how you find it and where you go. But basically, when you have Maya launched, if you go into About in the Arnold menu, you will see if there is a new version, you'll see a little green bar saying, hey, you need to update. And then you click the button, get the latest. And once you click the button, it will take you to the Autodesk Arnold portion of their website. You log in with your Autodesk username and password, and you should be able to download the latest version. Like I said, I'm going to demo that just so everybody can see the process and you can see how Arnold's supposed to work. So we'll get into that. No worries. Any questions so far? Everybody good here? Okay, good. Diamond, Josh is good. Daya, you good? Daya is good. And Allegra, you're good too? Okay. How about out there, Adriana, Damien, Elle, Griffin, Haley, Jasmine, Marley? Anybody have any questions? All good? All righty.
I'm hoping that you can go through a process of like a couple of different types of updates. I can see Maya is not requested the current version.
Well, this is the version we use in SAL. The current version is 2022, but it's really hasn't been tested all that much. And generally at Full Sail, we don't update until there's at least one minor update to Maya. Like we will not jump right in and start using 2022 in a class until we get 2022.1.
I mean, like, I've got 2020.2.
Right. So you should be able to go into your account and go up to Manage Products. And it should give you the ability to update there. And unfortunately, I'm up to date, so it's not going to do any good if I go in there and show you. So, all right. So file management with Maya and Arnold. Spaces are just spaces in naming and folders can cause a lot of issues. Now, Maya will not allow you to have spaces in a name of a node. It will automatically add an underscore, or it will remove the space or give you an error message. Now, outside of Maya, most of the time when Maya has to go look for stuff, it's pretty forgiving on spaces, but generally, when you're working somewhere, you don't want to have spaces in your file naming. That's usually not a good thing. Use underscores or use what's called the camelback style of naming, meaning your first word is lowercase And all words after that have a capital. This way you remove underscores, you remove spaces, and you save character. Well, character naming, character length, so that, a lot of times you may have like a 14 character length limit for a file name, or you may have 28, or you may not have a limit. But generally you want to keep file names short, sweet, succinct, right to the point, so that, for one thing, they're not confused with another file. And in certain operating systems, spaces translate into a backslash. So special characters you want to stay away from. Any of these that I've got listed here. So you got colon, /, comma, exclamation point, that's read as a command in Unix. You've got the little tilde up top here. You've got this little squiggly line. I can't remember what that's called. You got the @ sign, the pound sign, dollar, percent, the caret, ampersand, asterisk. That's usually used for searching, what they call wildcard, where just if you put that after a name, it's going to be, hey, find me anything with that name in any file. So plus, equal, parens, those are all basic coding things. Ask if you have questions, but people will, at Launchbox, I had a student once put a period before their name as their username. And basically, Maya could not read it because it reads it as a hidden folder. Like anywhere on the Mac, something with a dot in front of it, even in Windows, is usually read as a hidden name or a hidden folder. It took a while. They had to go to Apple to get help, because once you put your username in, it's kind of hard to change it and not lose everything that you have in there. So when you go to work on your assignments, always launch Maya first. Do not double click on scene files. That is the worst thing you can do. Launch Maya, set your project. That project is a project folder structure. So when you have an actual project folder structure, it looks something like this. And where are we? Nope, not there. Here we go. It looks something like this. It's got all these folders, and you'll see a lone file called workspace.mel. Basically, this means that when you start Maya, you set your project to this folder. This little file tells Maya, hey, everything you need to work on this project is inside one of these folders. So scenes, whenever you launch Maya, you're going to have a scenes folder that will contain all of the scenes that Maya knows is associated with this project. External sources or files are found in source images. Renders are going to go into your images folder. So it's really important that you make sure you understand that. Don't double click on any scene files. Always launch Maya first. Open the scene file from within Maya. All right, term ID for all submissions. We usually have year underscore month. That will be 2021-07. Not 2107. I know some classes want that. Just 2021 underscore 07. We've got it at the end of the activity list. Where are we? Right here. Right here. We've even got a reminder here. So you have been duly warned. All right. So enough kind of rules of the road. Let's get in, talk about rendering and cool stuff for today. Anybody have any questions before we get started? Anything not clear? So Marley, Jasmine, Haley, Griffin, Elle, Damien, Adriana, Diamond, Josh. Diane's good. You good, Allegra?
Yeah.
Okay. Excellent. Thank you. So I heard from Marley, but nobody else in the Zoom sphere. Everybody out getting lunch? What's going on there? Adriana's good. Thank you. Griffin's good. Jasmine's good. Thank you. All right. So kind of alluded to this a little bit, but let me see if I can get my stuff to line up a little better. Oh, well, I lost some fonts in my, I lost some fonts and then all the formatting I had was gone. Okay, better. There we go. All right, sorry about that. All right, so in order to make something visible in the real world or in rendering, we need three basic elements. We need either camera or your eyes to record the event, because if you can't see it, how can you verify it happened? If you can't record it, again, how can you verify it happened? We also need light, and we need a piece of geometry or a surface for that light to hit. You can have light, but if it hits nothing, it's not going to bounce off of it and it's not going to be visible. If you have a camera and nothing else, you can't record anything. You got nothing to take a picture of, or your eyes, you can't see anything. If you've got two of those, you're still out of luck, because if light does not hit a surface, it does not reflect off of it, we don't see it. Now, everything we see in our real world is a result of reflectivity. Light hits something, it reflects back, our eyes record it. Sends the information to our brain, we unscramble what our eyes have seen, and we interpret it. Now, in CG, we have one extra step that we need to do. We need to have a material on a piece of geometry. Material telling our surface what it's made of. It can then send that information to the renderer so the renderer knows how to display it. It's basically a description on how that material should react when it gets hit with light. We get that for free in the real world. So for example, underneath of our projector, we've got those shiny little vase kind of things with, you know, they look like dead twigs in them, artistically placed dead twigs. Okay, so our eyes see that because light hits it from inside the room somewhere, bounces off of it into our eyes, into our camera. We see the projector, it's got images that have been recorded, it projects it onto the screen. That light bounces off the screen, we see it, it bounces into our eyes. If we're missing any one of these components, if we're missing eyes or a camera, or we're missing light, or we're missing geometry, we have broken the magic recipe for visual description. So just keep that in mind when you're working. Failure for the renderer to work is usually a result of one of these three. Lights might not be working right. Camera might be off. Your geometry might not have the proper material on it, or may have lost its material description. That happens once in a while. I don't know if anybody's ever had that happen when you model, but occasionally your geometry will turn green. And usually if it turns green, it becomes a black hole because it has lost its material description, doesn't know how to display itself. So you have to reassign Lambert-1 or whatever it is you're using. So
It's so funny how much that green thing for me went from something like I was so panicked I didn't know what it was or why it was doing that. But then like after learning what it was and how to deal with it, it was like a very minor thing.
Yep, it is. Well, in the beginning, everything you do is major because it's all brand new and you're deathly afraid that you've broken something and you will never recover your work. At least that's how I was when I first started working in 3D. I'm like, oh my God, I broke it. It's never going to be the same. And then somebody will, no, just do this, you know, fix it. I was like, oh, okay, that's not so bad. So yeah, totally get that. All right, so let's talk about what rendering is. Rendering is not a new term used to describe purely CG processes. Rendering has been around since the early days of fine art. So let's talk a bit about what is rendering. Okay, and this is in the fine art sense. What does rendering do? Somebody says to you, you're working for an architect. Hey, I got a building. I need you to do a rendering of it for me. But you're not going to be using your computer. Okay? So, or, hey, there's a bottle of alcohol sitting on a table. Do a quick rendering of it. What is that process? You got a pencil, got keys, put them on the desk. Want to do a quick rendering of it. What is in a rendering? What makes it different than another process in drawing that we do, or any other process? Yeah, go ahead, Allegra.
Is it like because it's more of a like specific, like you're trying to capture sort of the dimensionality of it, or like specifically how it looks?
Okay, so how it looks, how do we define that though?
Like trying to make it really look real without stylization or anything?
Okay.
I don't really know. I'm just kind of guessing. I guess.
Make it look real. So when you say that, though, what does that involve?
Measurement, doing a lot of shading stuff, maybe.
Okay, what does that mean, though? What does shading stuff mean?
Like scribbling with a pencil, I guess.
Okay, but what are you trying to do when you scribble with the pencil?
Oh, make a shadow.
Okay. So how about shadow? Shadow only occurs when what happens?
And there's light source.
Yeah. What else? For example, what makes the carpet different from the desktop in front of you or your computer? Texture. What does that mean? I know it's one of those things where we use these words, but what do we really mean when we use those words? Go ahead, Josh. Okay, material. Material it's made out of. Okay, you're all exactly right. That is sort of the right course that we want to take. In fine art, generally, when you talk about a rendering of some kind, we're usually talking about how light and shadow react when it hits a surface. That surface, what is that surface made out of? Is it rough? Is it smooth? Is it metal? Is it glass? Is it plastic? Is it concrete? Is it fabric? Where does the light hit? Does it come from above? Does it come from alongside? Does it come from below? Does it come from behind it? Does it cause a shadow? So really, it's all about light and shadow. Well, even if we do a pencil sketch, we are trying to describe, an object on a table. There's usually going to be a shadow. Shadow implies light. Light implies there's a direction because the shadow is usually 180 degrees away from the light source. And what is the object made of? That gives us a visual clue. When you're doing a rendering for an architect, they may say a rendering, but what they mean is, I want you to show me what that glass will look like as light comes in through that glass and hits $1 million marble floor with really expensive exotic wood that greets people when they walk in through the door. Beautiful shape, beautiful design, nice materials. That's usually what's implied when we say a render. So rendering is not limited to just CG. We have it in fine art. We've had it in fine art for centuries, even before 18th century. Here, example of Frederick Leighton, right? Artists love fabric, the folds, the way the shadow, you can see the darker areas, that shadow, that's not where the light is. If you can describe how fabric looks draped over something and be able to describe it in detail with your paintbrush, with your pen, with your pencil, with your charcoal, you are pretty much at the top of your game, no matter who you are. Fast forward to a current mosaic artist, Samir Strati. He did Da Vinci's self-portrait with roughly 500,000 nails. Each one of those little points on the Da Vinci portrait is a nail hammered in by hand. Drywall, roofing, zinc, bronze, brass nails, black, white, doesn't really matter. As long as it gave the artist the look that they wanted, that's what he used. each one of his nails would be equivalent to what for us in CG? Yeah, a pixel. Now, our pixels happen to be squares, little tiny squares. His pixels happen to be round. And when he works with his pixels, he runs a real risk of damaging fingers and getting carpal tunnel as he's banging nails in repeatedly. You know, you can see he's got a wrist brace on. So that is a labor of love. So, you know, we complain about, oh, so many mouse clicks, my finger's going to fall off. Yeah, well, you know, you're not hammering nails into your computer, fortunately.
Well, what, at least like for early CG projects or something, like carpal tunnel is a very common thing for animators to get.
Yes. Because there was not a lot of ergodynamic workstations, computer monitors. People had trouble with necks and backs and wrists and heads because, you know, everything was brand new. People didn't know what if you're going to be there repeatedly staring into something, what are the detriments to, we're used to repetitive motion injuries, but what about like constantly being frozen in the same position? That's equally as bad as repetitive, you know, repetitive motion that causes damage to joints. So yeah, there was a lot going on. And also mouse buttons were not easy to click. We didn't have tablet pens. Yeah, it was bad. All right, so in 3D, our rendering process is basically converting our precious polygons that we model with into pixels. Bottom line, that's what we're doing. We convert polygons to pixels. We have 3 different approaches to doing that. We can take our polygons and send them through software rendering, take our polygons, send them into hardware, or take our polygons, send them into what is called vector rendering, where we're kind of changing it a little bit up from normal direct polygon pixel conversion. So what's the difference? So software rendering apps, hardware rendering apps, and vector rendering apps. Well, let's define software, hardware, and vector. First off, let's do vector. Anybody know what vectors are? Allegra, you want to take a shot?
Sure. Well, I don't really know the definition, but I have like examples, I guess. Like one thing I think of is like Photoshop versus Illustrator.
Okay.
I know that in the vector-based work, you can zoom in and not lose resolution.
Okay.
And that is pretty much all I know about vector-based work.
Okay. So let's define first off, what are vectors? It's a lot simpler than you think.
Like an arrow or something?
Not really. That arrow can be defined with vectors. It's catch-22. Which came first, chicken or the egg? Who crossed the road first, the egg or the chicken? So vectors, anybody ever do aviation in the military? Okay, well, vectors are a series of numbers. In aviation, it's usually like altitude, direction, wind speed, and distance. So basically, it's a set of numbers. So when you've got vectors, you are basically taking points, numbers. So for example, in a vector, you've got 2 points. You can connect those points together with a straight line. Right? Point 1, point 2, your vectors are 1 and 2. That creates a straight line. Now, it can be more sophisticated than that. It can be, you've got 2 points, but your line doesn't necessarily have to be straight. It could be curved, depending on, you know, the type of curve you want. You can usually get something like that. So sometimes people would call this like a polyline, where it is a straight line. You've got a curve here, but then you get into something like Illustrator, which has more sophisticated curves, which out of 2 points, you can get something like this. And that's because Illustrator has what are called Bezier curves, which have little handles on them to control how that curve moves from its departure point and arrival point. So here we just have a curve, but here we have a complex curve, a Bezier curve. And that's usually what applications like you mentioned Illustrator. Illustrator is a vector-based graphics program. There's also, I think, Corel Draw. There's a couple of others out there. There's some open source ones that compete with Photoshop, or not Photoshop, but compete with Illustrator. But basically, they are points in space. We use those curves to define shapes. And you know, with Illustrator, you've got more than 2 points to make a shape. You need at least 3 points for a closed surface. Well, you could even get away with 2 technically, but 3 is really the ideal. Just like with a polygon, right? Polygon requires you to have 3 points and 3 sides. Does that make sense? But out there in the Zoomosphere, any questions? Make sense? Okay. So we've got Illustrator. Well, you know what? Instead of me just drawing on that part, let's just get rid of that. And let's just select this one right there and turn that down. All right, so besides Illustrator, Corel Draw, Maya can do vector rendering. Unity, Unreal, CAD, all vector-based. CAD, computer-aided design. It's where most of our industrial design is done. Manufacturing is done out of there. Cars are designed in CAD. Pretty much anything that we have in modern life is designed in CAD. Computer-aided design. Yeah, go ahead.
So what I'm getting from this kind of thing is like the difference between a vector-based thing like Illustrator and the pixel-based thing like Photoshop. Would it be like, for a pixel thing, you would draw a line and it would just only have what was drawn and defined, so eventually you keep zooming in and you're gonna lose definition because you can't, like you weren't infinitely zooming in while drawing it. But the vector one is more like math-based.
Mm-hmm.
So when you zoom in, it already has like some kind of, like it already has whatever line you see calculated number-wise.
Yep.
That's kind of why you can keep zooming in.
Yep.
Okay.
That's pretty much exactly what it is. Vector-based, since it is math, has no resolution. It's not resolution dependent, meaning that math calculation can define a curve if you zoom in microscopically, or you zoom out and make it as big as the side of a building. That curve will still maintain that same quality, in theory. Whereas in Photoshop, that is basically what we call raster, which means those are pixel-based lines or pixel-based shapes, meaning they have a finite resolution based on how small the pixels are and how many of them there are in a given space. So in a photo, it looks really good at one resolution. You kind of zoom in and it starts to get broken up. It starts to look chunky, splotchy. It starts to look like Lego blocks. So you reach a point where those pixels are actually taking up more screen space than they were when they were further back. So yeah, fixed based versus non-fixed. Yep, that's exactly right. All right, so now the difference between software and hardware. Hardware is when we use our computer. Now, it's kind of a misnomer. I say software, I say hardware, but in order for hardware to work, it needs software to drive it. But the difference between software rendering and hardware rendering is the software in the hardware is kind of built into the code, it's built into the chips, it's built into the memory of that device. Whereas software will read things in, calculate them, and then spit them out. That kind of makes sense? So to put it really simply, software is more time-based and hardware is more immediate, real-time based, what we call. And that's really the difference between a game engine and watching a movie. A movie is pre-rendered. It is, all the frames have been carefully, recorded and lined up in order. Whereas in a game, in real time, you are a player moving around and the game engine has no idea where you, the player, are going. And you, the player, may not know until you walk through that doorway and see what's on the other side. That will determine where you go next.
So, and is that like hardware rendering takes place on the customer's computer, but software takes place on like the computer that's producing?
Sort of. It could take place all on your computer. Like you play a video game, it could be on your phone, it could be on your computer, but you are moving around in real time. And like I said, there is no preset script for you to follow. Now, granted, in a game, you are guided by certain things. All games kind of have a large playground, but you are still in a world that is finite. Software, you are working on something and you are recording it in theory to be a slightly higher quality than real time. Like I said, that's kind of a misnomer because real time has gotten good enough for us to use in feature film and in TV.
Yeah, they used it in The Mandalorian.
Yep. And it is pretty much being used in any new production now. I mean, The Mandalorian didn't really break ground with it. They were utilizing technology that was around, but nobody had really used it in an actual production with deadlines before. But all the technology existed. The LED walls, Unreal is what they used in there. The ability to run the graphics cards, that didn't really exist until, honestly, until the 20 series of NVIDIA graphics cards where ray tracing became a thing to do in real time. Because you need ray tracing for accurate reflections, for refractions, for the way materials look, and the way light behaves. So once we started to do that, you know, all they do is they buy a ton of graphics cards, hook them all together, and it becomes a, you know, basic monster graphics card system that will run the LED walls. And the nice thing about the LED walls in The Mandalorian is they use them for lighting. And the actors were not in a green screen or a blue screen. They could actually see the environment they were in. So consequently, for production, it was just the greatest thing, because all of a sudden everybody could be immersed in the environment and be able to, I mean, it makes you appreciate great actors who can act in front of a green screen and not know what the hell's going on. But when you've got a really good actor in an LED wall, you know, they basically talk about losing themselves to the character because they are so immersed in it that they are the character. You know, so there's a whole lot of potential.
And I imagine that's gotta like be helpful in some regard to like reducing the compositing.
Oh, yeah, because they're doing pretty much everything in frame. They no longer have to do, you know, well, they still go on location. Let's put it that way. There are certain things that you still need to do on an actual location, because no matter how good you do it, you can't quite recreate the feel of an environment. But if you're doing a set extension, you know, meaning you're out there in New York and you want to blow up buildings, well, you're not going to go to New York and shoot. You know, you're going to use a virtual set of New York and you're going to blow up buildings like they did in the Avengers, the first Avengers movie. So, you know, it's one of those things where it's given us the ability to have immersive acting, to be able to create real lighting where everything that we shoot in camera, that's the light from the LED volume. It creates enough intensity where it lights the characters with the light levels they want. Granted, they still may artistically throw a few extra lights in there just to make the character pop out. But for the most part, that's exactly what the camera sees. And as they move the camera, the LED wall will move also if it needs to. And it's real simple. I mean, if they're going to do a cut to another area, that's pretty easy to do. You just load in your scene and off you go. You don't have to build an entire set. Of course, you build practical props to go in front, but it's not going to be the same as building a whole entire soundstage. All right, so software, hardware. You'll notice that a lot of the software apps also will do hardware, like Maya. For example, Maya has its own software rendering, which, you know, in the 1980s, 1990s was good. But quite frankly, you know, they never really kept up with the technology. That's why Autodesk or whoever owned Maya at the time always partnered up with somebody else. Before it was Arnold, it was a program called Mental Ray, which we used to teach here. Mental Ray was owned by a company that was bought by NVIDIA. So NVIDIA kept Mental Ray for a while. And then, you know, NVIDIA was going on with their real-time graphics cards and real-time ray tracing, real-time lighting, real-time rendering. They stripped out all the good stuff out of it and then consequently killed the product. So Autodesk bought out Solid Solid Angle, which and that's who owned Arnold, and that's our new renderer. Now, we were using RenderMan for a while because RenderMan is state of the art. And when when Autodesk first bought out Arnold, it wasn't quite integrated well enough, we didn't think. So we decided to go with RenderMan for a while, see how Arnold went. The new version of Arnold that was bundled with 2020.4, that included a lot of things that were not in the original release of Arnold, like denoise. Denoise is a really big issue for rendering. Get rid of all that grit and grime and all the little splotches on your scene. You can throw as many samples in there as you want, spend all the time in the world, and you're never going to get rid of everything. So having these filters that are available, and quite frankly, every renderer's got filters that denoise now. V-Ray, Arnold, RenderMan, it made a difference, and we were able to actually go back to Arnold. But software, iRay, you guys are familiar with iRay, at least you should be. That's what's in Substance. When you want to render something out of Substance, you let it go and it iterates and it, eventually cleans up. That is a program called iRay that's built into Substance Painter. Hardware, Maya, the viewport in Maya is hardware rendering. That allows you to render, immediately when you create a shape. You can look at it in wireframe, you can look at it in shaded, you can look at it in materials, you can even look at it in lighting to a certain degree. Believe it or not, Unreal, Unity, Substance Painter all have hardware. And actually, Unreal also has software rendering, as you guys will find out, because we're going to actually use Unreal to software render some animation. All right, let me clean this up. So what's the difference between them? Well, we kind of talked about the differences. Software rendering occurs on the CPU, that's your computer. It runs a program, calculates the frames or frame, the objects that it needs to render, and then takes its time and outputs a generally higher quality image than hardware. More flexible because we have the luxury of time, but more time consuming. Now, hardware generally occurs on the GPU, meaning your graphics card. Typically lower quality when compared to software, but honestly, with the newest version of NVIDIA graphics cards and Radeon graphics cards that use ray tracing, it's really hard to tell the difference. A lot faster. A lot of times we have what are called a maximum number of lights. Now, when we talk about lighting, we're talking about what's called dynamic versus static light. So for example, all around our walls here in our room, you could consider that to be static lighting. If we were in a game engine, we walk into this room, we could get this room to look good because we could bake our lighting, meaning we would basically have the lighting in with our textures. We'd save a lot of time, but as soon as your character goes up to a wall, so for example, if I put my hand here, I don't know if you can see it. Well, not much of a shadow there. So I will depart from the camera for a second. So we go up here. As soon as I interact with this light coming from the projector, this is now a dynamic shadow, moves. So there's a difference between dynamic and static lighting. Dynamic lighting, you usually reserve for things that are important. There's no reason in our room, if we were building this in Unreal, to have dynamic lights on the walls, unless we interact with them. So that's what we mean by maximum number of lights, dynamic versus static lighting. Now, there are a couple of other lighting issues. And one of them is for a light type called a point light. A point light is like a bare light bulb. Bare light bulb shines light in all directions. If you shine light in all directions, you are also going to get shadows in all directions. But in a game engine, we can limit the shadows to one or maybe one or two axes of our point light. That will save render time because we're not trying to calculate everything dealing with that light. Now, another type of light is called an area light. A lot of times they're called physical lights because based on their size, they will react differently. So when you take an area light, which is basically a big, broad surface of light, similar to kind of our projector screen, that is a big area of light that's being illuminated from our projector, but it also reflects a lot of light to us. So it reflects a lot of light, and depending on the size of that area light, whether it's small or whether it's large, the shadows look differently. So physical light, very expensive because it has to calculate size of light, distance from light to character in order to get correct shadows. Again, that's pretty expensive. And that's what all these new rendering systems work on. Unreal's got a whole brand new rendering system that's in Unreal 5, which is still, I think, in beta testing. But they have released it to the public. I haven't had a chance to play with it yet, but I understand it is pretty awesome. And I'm not quite sure my computer can do it. All right, so that's hardware. And we get into vectors. For Maya, this is Maya materials only. But it gives us the ability to do things like wireframe. We can do line art. We can do toon art. But has a couple of caveats. One is you have to be able to output it to a format that's usable. Now, various formats, Adobe Flash, the old Shockwave format. I'm not sure they even offer that anymore, but you can output as Adobe Illustrator, meaning you could render a frame out of Maya, take it into Illustrator, and it will show up as vectors. It's going to be 2D. It's going to look 3D, but it'll still be 2D. EPS, nobody uses EPS unless you're going to print for a book or a magazine or some kind of physical publishing. The thing that we really use vectors for are SVG files, scalable vector graphics. Those are the things on the internet where you can zoom in and look at something and the resolution, it gets bigger, but the resolution stays the same. It doesn't get blocky or chunky looking. You can zoom out, it gets small, but you don't lose any resolution. All right, rendering, software rendering, Maya versus Arnold. Well, Maya's old technology, honestly. Hasn't really been updated since maybe the early 2000s. But the one thing that Maya always had going for it was they developed this interactive photorealistic rendering tool called IPR, which basically is what all modern renderers use now. It constantly runs and updates. So you make a change, it updates your render in real time, constantly redrawing the screen. Now, it's a really good idea, but in the early days, computers did not have very fast processors, did not have a lot of memory. So it crashed a lot because you would fill up your buffer or the memory, and then it would stop working. Now, Maya originally started out as what's called a scan line renderer, which means it would render pixel by pixel, line by line, row by row, and that was how it worked. It looked at the image, created a pixel, looked at the image, created another pixel, right? That is fine, but when you work with that, you don't get reflections, you don't get refractions, you don't get rays being shot out into a scene to calculate where objects are. And not only to calculate where they are, but what they are. Are they transparent? Are they solid? Are they shiny? Are they dull? All things that we take for granted in our rendering, in our look. That was not the case until ray tracing came along. Ray tracing came along in the early to mid 1990s. Now, the deal with that is it spawned a whole bunch of other kind of ray tracers, or not ray tracers, but well, yeah, ray tracing types. The newest one, kind of what we're dealing with now, is something called path tracing. Path tracing is basically rays shot out of the camera, and those rays are only concerned with what the camera can see, whereas ray tracing traces every object in your scene, whether it's visible to the camera or not. Path tracing is a lot more accurate because it's only worried about with what is seen by the camera. So if a ray falls out of the scene but comes back in, path tracing knows it and will calculate that. If a ray falls out of the scene and doesn't come back in, path tracing knows that. As soon as it leaves the scene, it just doesn't care. So Arnold was started by Solid Angle way back in 1997. The modern version that we use today was co-developed with Sony Pictures ImageWorks in 2004. So built in to Maya now, thanks to Autodesk buying Solid Angle, but they make plugins for Maya, 3D Max, Houdini, Cinema 4D, Katana. They used what's called a Monte Carlo ray tracing renderer. Monte Carlo simply means it sends out random points into the scene. And every time it does another pass or an iteration, it sends out randomized points again. And honestly, Monte Carlo, from what I can gather, is it's basically a math function that re-randomizes a random array, which is kind of weird to me. Like, how do you randomize something that's random? But apparently you can do that, and that's what they do. So every time it sends out rays, it re-randomizes them. So in theory, it should hit a different point or a different spot. Has IPR, really good stuff. In its render view, it also has the ability to denoise. It has a denoise filter in it, which makes it really useful for us, considering we don't want to spend, 3 hours rendering. We want to get a good quality image, be able to get rid of a lot of noise to the point where we can then run the filter and it will clean the rest of the noise up for us. So advanced ray tracing features like path tracing, which I mentioned, kind of is only worried about what the camera can see. And it shoots out multiple rays, whereas ray tracing sends out one ray per pixel. With path tracing, multiple rays will hit the same pixel. And depends on what that pixel had happened the last time it was calculated, may change how it looks. We get global illumination, we get caustics, and we get image-based lighting, which allows us to use images for lighting. Now, caustics, probably not able to see it too well here. Let me see if I can put my light on. But basically, caustics are what happens when you have light shining through an object. Like all the little lighting areas that are kind of visible very subtly inside through the water bottle, like in the middle there, that is caustics. And those are pretty complicated to render. But in the end, with any renderer, we're still taking our 3D package, our precious 3D art, and converting it into 2 dimensions. Yes, I know there are stereo cameras, there are virtual reality headpieces that you can wear, but in reality, they are all still flat screens, just either offset by timing or offset by color. So whether it's an image sequence, i.e. movie, or just a single image, we're still converting 3D to 2D, polygons to pixels. And purpose of rendering, we want to produce the highest quality image in the least amount of time to meet your production deadline. Every time we say something is expensive in production, that's time. And the whole idea is you want your render to be high enough quality where it meets the threshold of quality for your production, but yet in reality, you want to be able to exceed, or not exceed, but you want to be able to come under the allocated time for rendering. Because if you can do that, you will never be out of a job. If you can get something to come out really good looking really quickly, there are always jobs for people like that. There are people who spend their whole lives trying to figure out how to get something to render quicker. Even in real time, how do we get that camera to move without any latency? Because, you know, face it, if you're dealing with a big giant LED wall, like the size of this room or even bigger, right? That takes a lot of muscle to move. When you move the camera, it's going to take a while to refresh all those pixels. So you got to be able to find a way to do it either cleverly with the camera, inside the camera, where, you know, you may move it and, you know, you have a character walk in front of it while it refreshes or whatever is going on. But there's always ways around issues that we have in production. But we're still describing light and shadow and how it reacts to a surface. So a couple quick examples. Scanline. Scanline is the original line by line, row by row process of rendering. Renders faster than ray tracing, but does not display reflections, refractions. You can see through objects, but it just looks clear. It does not bend light, and it does not use actual transparent shadows. They use what are called depth map shadows. They are maps. Anything that is being blocked by the light creates a solid shadow, a map. Now we move on to ray tracing. Generally, one ray samples a pixel, single light ray or single camera ray, depending on what you're doing. Displays better reflections, refractions, transparent shadows, takes more time to render. But now we get into path tracing, which samples a single pixel with multiple rays. So now we can really get a feel for what that looks like. Shoots rays from the camera. So the camera obviously is our eye in our rendering process that allows us to record better results. More accurate reflections, more accurate refractions, transparent shadows. We can get caustics. Looks a lot more believable and realistic. What's called Scanline. That's the old school. we got ray tracing, and then we got path tracing. Path tracing is what all modern renderers use. RenderMan's a path tracer. We were evaluating V-Ray also for our class. V-Ray is a path tracer. Even in Unreal, Unreal Engine has a path tracing renderer. All right, file formats in our class. When we output out of Maya using Arnold, we're going to be using what's called OpenEXR-half. That's the native file format that Arnold likes to output. In fact, that's really kind of a standard industry, high quality, very, very, very low compression, very lossless file format. We use what's called OpenEXR-half, which means since we're not doing 2K or 4K or 8K renders, we don't really need all the muscle of a full float 32-bit image. 32-bit image has thousands, roughly about 4,000 levels of gray between absolute black and absolute white. We don't need all that. 16-bit is roughly half that. You know, still a couple thousand is still quite a impressive number. Compare that with a normal 24-bit image that we get off the internet, which is called 8-bit. 8 has 8 bits of information, which is roughly 256 levels between absolute black and absolute white. So OpenEXR is what we use, but honestly, most of our output is going to be RGB 24-bit. And we're going to do that in Photoshop, because Photoshop is probably the best image editing tool out there. Now, a lot of people use it for painting and drawing. It's really good for that, but honestly, it is image editing. That's where it got its start. Now, like I said, RGB images that we get off the internet, or even we create out of Maya, or not out of Maya, out of Photoshop, they are 24-bit images. Now, sometimes it's confusing. I said 32-bit image, 16-bit, and now I'm saying this is 24. All right, well, let me see if I can clarify that a little better. All right, this is 16 bits per channel. This is 32 bits per channel. RGB images are 8 bits per channel. So we have 8 for red, 8 for green, 8 for blue. 8 times 3 is 24. That's where you get your 24. And honestly, these images, when you combine red, green, and blue together with that level of bit depth, you can roughly get 16.5 or 16.5 million different colors, shades in your photo. That for us is normally what we would consider to be a continuous tone photo. That is what we are used to seeing as a full quality image. Whether it's old school, I took a picture with film, how quaint. Had it developed, how quaint. Put on paper, how quaint. Look at the image. That's usually continuous tone image. Whereas we look at these in our monitor, we don't see the pixels. We just see a smooth continuous image. Image like this one right here, 24-bit. Eight bits per channel, 16.5 million colors. I can easily see different shades of green, different shades of brown, different shades of reds, all in there. All right, so image size. When we're dealing with image size, we are dealing with pixels, and it's always the width, then the height. So whenever we say, I need a 720 by 480 image, that's going to be 720 wide, 480 high. So for example, here, this is 480 by 640, 480 being the width, 640 being the height. Now, when we deal with images, we are also dealing with something called resolution. Resolution is how many pixels can we cram into a given area? So we cram pixels in. The more pixels we cram in, meaning we have to make them smaller, we get better resolution, we get better line, we get better shape description. To give you an idea, if anybody's ever watched standard definition television, basically rabbit ears, TV with a curved screen on it, you can feel like the radiation on it. Okay, that was analog television. And analog television was basically, or I should say broadcast. It was 640 by 480. You could have a huge killer, humongous screen, but you were still getting that same resolution. Now, right around the mid-1990s, we switched from analog broadcast to digital. We took all of our big waveforms from, broadcast television, converted them to ones and zeros, got a much smaller, narrow bandwidth. Consequently, we got a little better resolution. We went to 720 by 486. Now, if you were doing HD, it would have been like 405, but it was still 720. And this, by the way, was standard DVD resolution. This was our first generation digital video that we had. Many of you probably had, I don't know if any of you ever saw VHS tapes. No? If you did, I'm sorry. If you didn't, you're fortunate. They were good, but as you played them, they wore down and they got nasty looking and snowy and grainy because it's magnetic tape that just degrades over time. Whereas a DVD, as long as you didn't scratch it, you cleaned it, you put it in your player, you got the same quality pretty much every time you played it. Now, we started with, that didn't last all that long, right? DVD lasted maybe 10 years at the most, not even that. I think DVD lasted about 8 years. And then we started to get into the HD wars. HD meaning the aspect ratio that we currently have now, which is high definition. It's wider than it is taller. There are a couple of different aspect ratios. You had 720i or P, I being interlaced, P being, I forget what P stood for, but just two different ways of broadcasting those pixels. And 720 meant you had a 1280 wide image by 720 high. That was first generation. That lasted maybe a year, not even that. Because then we started to have HD wars and Blu-ray took over. Blu-ray is our version of HD that is still pretty prevalent. 4K is now the big deal, but this is basically 2K. This is 1920 wide by 1080 high. Now, when you say 2K or when you say 4K, it's like 4096 by 2550 something. I forget what it is. To give you an idea of where we are, traditional 35 millimeter motion picture film, the size of the actual frames that they used to put on the projectors in old school movie theaters, that was a 2K projected image. It was 2048 by 1556. So all these numbers, all you have to worry about is we follow the HD aspect ratio. That means it's wider than it is higher. And for our class, we're doing mostly what is called HD 540, which is basically 960 wide by 540. And it's roughly half of this. Why do we do that? Well, to save you guys render time. And if you can render it out at this size, you can render it out any aspect ratio. It's just going to take you a lot longer. Is it pretentious to say some movies look better on VHS? Depends on how old your VHS movie is. If it's really old and the magnetic coating on the tape has started to degrade, I would say, I don't know, El, I don't know if that's going to hold up. But it's kind of like the difference between digital audio and analog vinyl audio. If anybody's ever heard a vinyl record and then heard the digital version of it, some people prefer that vinyl sound better. Some people say it's a little fuller, a little sweeter, maybe because it's got so many imperfections in it. We're just used to that, and that, you know, we hear that in our real world. But again, it's, you know, it's going to be a very personal experience. Same for you, El. Whether, you know, maybe you have a nostalgic love for a certain movie in VHS and it looks good that way. Well, I can totally understand that. Tristan, vinyl is better. Yeah, I would say that until your vinyl records get scratched or you get a lot of dust in them, and try and clean it out. And then you get a lot of static and pop and noise. So yes, I agree. I'm a vinyl lover. I grew up with it, but you got to handle them on the edges and you got to be super careful with them. And I have a ton of records. Do I listen to them much? Nope. I listen to the digital stuff. In fact, most of my stuff I've bought digitally just because I'm lazy and I don't want to worry about it. I just want to be able to put it on my phone or just play it somewhere and not have to worry about, okay, I want to play this, but I need a turntable and I need an amp and I need speakers. So subjective. All right, now when we render, we utilize something called anti-aliasing, which is pretty much built into every modern renderer to some degree, right? Before we had anti-aliasing, when we rendered, we would, remember, we're rendering pixel by pixel, right? Whether we sample the pixel once, we sample it many times, or we just print that pixel as is, we're basically dealing with squares. So when you're dealing with squares like Legos, straight lines, right angles, they look absolutely great. Can't get any better than that. But as soon as you make a diagonal or you make a curve, then you've got another issue, right? Lego doesn't really make great curves or great diagonal lines. You wind up with stairs. And you wind up with areas that don't necessarily conform to equal spacing. Like for this curve, right? It doesn't happen to go corner to corner. It goes a little bit less. So in order to do that, in order to get that line to look right, we've got to skip a couple of spaces in there. Well, that makes it look really chunky and blocky. But with anti-aliasing, we kind of blur that edge a little bit, meaning we interpolate it. We basically add a few shades of gray in between areas. We might take an area that's black, make it dark gray, take an area that's white, make it light gray. And this way, when you kind of squint, you know, the image on the right looks a little smoother because we've actually made it a little softer on that edge. So anti-aliasing allows us to kind of clean up the edges on our models when we render. Now, honestly, most interfaces like Maya in the viewport have an anti-aliasing feature. It's turned on automatically because they want your stuff to look smooth. So this anti-aliasing process is really kind of one of the steps that we utilize for smoothing out a render. The other, path tracing, where we sample a pixel in more than one place. This way we can get a really good idea of what the pixels around it look like and how to more accurately define it. And when we get into sampling and rendering, we're basically going to be doing it in passes. And that's how Arnold, that's how V-Ray, that's how RenderMan, that's pretty much how every modern renderer works. Each pass that it does refines the image a little bit better. All right. Any questions so far? Right. Diamond, you're good. Josh, you're good. Daya's good. Any questions, Allegra? No? Okay. How about out there? All right. Griffin is good. Tristan is good. Okay. Adriana, any questions? Oh, Adriana's good. Okay. Damien, L. L's good. Damien's good. All right. All right. Well, this is a good time to take a break. We'll take a short break, 20-minute break. And what that'll do is give me a chance to basically offload this first part of lecture on my computer. I'll render it out while we're on break, upload it to YouTube. Should be able to get that done in 20 minutes. And then we'll start up again and we'll talk about rendering in Arnold and what's going on with our assignments today. All right, so let's see. It is 9:16. So let's come back at come back at 9:35. That should give me a chance to get everything rendered out. We'll pick up. And I'll see you guys back here in 20 minutes. Now, in order to do this, I do have to end the session because Zoom will not render unless the session is closed. So I will start the session up as soon as my computer is free. So I will see you guys in 20 minutes.